Good afternoon, all of you. I am PLN Raju. Today I am talking about technology trends in a GIS. GIS and remote sensing, they play a very important role. Even you see nowadays a lot of information is coming from the satellite remote sensing, and we create information using GIS. We create information using global navigation satellite systems. And if you have seen that recently that disaster which has happened in Andhra Pradesh, Visakhapatnam area, so there also they are using this technology, latest developments. Even Chief Minister is very much keen to use these technologies. One is you use GIS technology, the information created of areas, number of villages, which are the villages in low-lying areas. And then another is, suppose if the disaster happens, how many areas is going to flooded. And then once it is flooded or damaged, and then he also asked that the local people where the things happen, even if you are one of the candidate who are living in those areas, so you yourself can also take a picture, photograph of the damaged things, and can also upload to the main server. So it is something like a crowdsourcing. So what NRSC is a National Remote Sensing Center, which has developed this app, and they also uploaded on the NRSC website. Anybody can download that, and then the information you can also upload the information. Finally, that information which is uploaded, it can be used for rehabilitation, relief works, and reconstruction of the activities. So it will also help the government. So basically, the administration, the implementation of the issues. So everybody can also contribute in that. What I wanted to say that in all these things, your technology and your knowledge, what you acquired, so it is coming into use. So that is what I wanted to say. Even the government at the center also, so they are also encouraging all the ministries to use the technology, the remote sensing technology, and particularly, and then GIS. GIS is basically combining all the information coming from remote sensing, coming from GPS, etc. So before go further, I wanted to summarize. Say in a GIS what we are doing. So a GIS what we are doing is we are getting information from various sources, and then we are combining that information, and that information, whatever it is combined, it is further used for various applications. And then coming to that technological trends and technological role in a GIS, if you see that maybe GIS when it has started in 1960s. So, but if you talk now, we talk about what I said is a crowdsourcing. It was not there even 5 years back. So now the crowdsourcing has come. If you go further back, see there is no network like earlier. Like what I am now doing is I am able to talk to you, all of you, in the internet environment. I am able to give the live lecture. So this live lecture, say it is internet was not there in 1992 or 95, and then there was no network previous to that. So that means the technology developments. Suppose what I wanted to say is that if you talk about the technology like internet, so when internet has come, so internet is effectively utilized in a GIS. So like a web GIS. So combination of desktop applications and internet, it becomes a web GIS. See, basically somebody carry out a project in a GIS. So that whatever is carried out in a GIS, and then it used to be limited to that particular place, that a particular person, that particular desktop computer. So, and then if there is a department is there spread all across India, and then they wanted to use that information. So it was only limited to the desktop. So when internet has come, so then internet technology is integrated and WebGIS technology was developed. So what is the advantage of WebGIS technology is, so without having a GIS package at the client side, you are able to use that GIS information, and then it will also help you to take the decisions. Like what example I have given is the crowdsourcing. So suppose you collect the information on the ground and then send that information to the server. What it is doing is it is directly going to that place where you have collected. So that means it is also recording the GPS location of that place. So then it will be sitting exactly on the place, on the image, on the map, on the server. When is GIS, if you talk, I wanted to say it was a desktop computers. Earlier to that, mainframe computers, mini-frame computers, and then when microprocess based development of computers taken place, so all these technological also have got the boost. So, and then people started using it. So earlier it used to limit to only few organizations who can spend tens of thousands of crores, and then now without having any resources like a normal PC computer, normal laptop computer, normal mobile devices, so they are also integrated with all the information, which was never thought that it will come to such level. And then internet, as I mentioned, so without having a GIS, we can also use it. And another development is crowdsourcing. So, and then there are various other developments. One is in the hardware side, you have computers, how the computer is revolutionized, and how the processing powers has increased. I think you might have heard about a Moore's law. So that transistors which are there on the chip, they are basically increasing to process our computers. So if it is something now, so in 1 year time, so they are going to double. So but at the same time, cost is going to be the same or less. So that means you are getting computers or hardware which a higher processing capability and then at the same cost or at the lower cost. If you talk about a laptop computer or a desktop computer example is something like it used to cost when it micro PC and when it used to be a Pentium or PC 286 and PC 286. That time it used to cost around 2 to 3 lakhs one small computers. So now the same you are able to get in 10,000 and 20,000. So one is hardware the development, another is the software. So the software also the applications used to be specific applications. So you talk about overlaying applications and then modeling, and then now more and more applications are coming with higher processing and higher modeling capabilities. You can also think of some prediction and then the future, what will be the future scenario, etc. And then you also have development in terms of having the data. Suppose when we talk about a GIS, so it used to be that whatever you generate, you are able to generate within your limitations, or you are doing at one place. So nowadays there are a lot of efforts are made to generate information from the organizations, and then that information is made available to the public. Suppose we talk about satellite data. A lot of satellite data is generated and made available through Bhuvan, so that people are able to see that satellite images of different resolution for different areas, and then they can also see that what are the thematic layers are generated under different projects. So you can also use them, or you can download them, or and then there are a lot of developments have taken place in terms of availability of the data, one is, and then availability of information is generated from various sources, and then they are also made and kept in the public so that public can use that thing. So then when you are using, so that seamless integration is also one more component. So another is once you get the data, even how to do analysis or processing on the web, something like processing services. So that is one more application which is also growing very fast. And then if you talk about integration, so a lot of functionalities available through the software, so that we are able to do the better integration of various informations and coming out with the new scenarios and newer applications. Even in terms of creation of the data, you see, as I said in my initial lectures, when you start creating information, digitizing or scanning, so this is a major part of data generation. So there also a lot of developments have taken place. So and then all this basically helping GIS and the remote sensing community. So the first slide it was telling about how we have graduated, like starting from aerial photography, then satellite remote sensing, and then when satellite remote sensing came, we started interpreting satellite images. Earlier we used to do manually using hard copies, and then now after that remote sensing and digital image processing, how to analyze the data digitally instead of manually, and then combining basically satellite remote sensing and GIS. So that is something like a 1990 and sometime, and then another revolution taken place is the satellite remote sensing, GIS, and then integration of the global positioning systems in somewhere 95 2001. And then beyond 2001, so a lot of developments have taken place like internet GIS, now crowdsourcing, and then now everybody is talking about virtual earth. So how to bring that real environment into the computer. So everything what is there on the ground, how real you can bring the information into the into the system, so that everything you can process and analyze and then take further decisions based on that information available for us. If we talk about GIS, we are also aware of that. When you talk about the GIS, there are various components in GIS, like a hardware, software, and then data, and then you have people, and then one more is added here is the networks. So earlier, when we talk about a GIS, nobody talked about the networks. See, now why we talk about the networks is because when we want to use a GIS, we have to create a lot of information, lot of data creation, that is digitization and themes creation, etc. But that one has to do personally, and nowadays a lot of information is generated over the time, and that information is available. So now we can say I can get DEM from one place, from the one source, and then satellite data is from another source, and then what is the road network information maybe from Survey of India, and then some themes generated by land cover map from National Remote Sensing Center. So all this information is coming to you, not physically, but they are there on the online. So you are able to connect in the network and bring that information to you, directly integrate them. So that's why. So now you can also say that GIS is not 4 components; it is 5 components. And then everywhere there are developments have taken place, as I mentioned earlier, in the hardware also. So it is, and then as far as in the hardware also, the processing speed also is increasing, and then storage capacity is also increasing. And then similarly, if you say networks, so then it is also, we talk about wireless network and wired network. And then nowadays, people are talking about a gigabit speed. So earlier we used to speak only in the megabits, and then when this internet came, that time it used to be kilobytes per second. So that is very small data. So when the bandwidth increases, when the capacity is increasing, so now we are not only limiting to the passing of information of a limited information, we are also trying to pass a huge amount of information. So at the world over, so a lot of developments have taken place, like we talk about a 2G, 3G and 4G. So here basically data rate, basically the data rate is increasing. So it is increasing, earlier it is a 2G. 2G is limited to I think hundreds of kilobytes now. And if you talk about 3G, it is up to 2 megabits per second, and 4G is it is something like a gigabit speed. So somebody sent a file of maybe a satellite data, use satellite data, and then you will be able to download in fraction of seconds. So and then there is something we are generating a video of these lectures. So then if you have a higher connectivity, high bandwidth facility, then you are able to view the videos seamlessly. And then in India, the better thing happened is National Knowledge Network, where they established backbone facility up to 10G level. So that means the backbone is helping to do a lot of basically acquiring the information. At the same time, you can also on the fly, on the go also you can do some processing. Accordingly, your other functionalities also people trying to integrate. So when you talk about online, so you can also think of what is that. One is crowdsourcing and another is the cloud computing. Cloud computing means you are generating a computing facility on the cloud. So you can use hardware, software. See, what we are doing is, suppose you wanted to have your own network, your own processing capabilities. What you have to do is you have to buy an hardware, you have to buy a network devices, and then you have to buy a softwares. So if somebody is offering those things on online, so instead of, say, nowadays even you buy these things becomes obsolete in say in 5 years time, and then the amount is spent is that huge. And then somebody says that I can give all these things, you can do all these things without having any infrastructure at your place. So that means they charge per usage base, and then maybe sometimes that cost will be much lesser than you buy and maintain yourself. So you may not be able to use optimum to the 100% level, but if you have the resources which are on payable basis, so that also helps basically to you in a better way to economize the things. So when GIS is started, it is something like we generate maps in two-dimensional way, and then understanding that information, you also require some functionalities like visualizing those things in a 3D environment. And then you can also link whatever you generated. Suppose now, what is that? Cyclone effect has happened in Visakhapatnam, and somebody wanted to know exactly what is the damage. In GIS, you can make a layers, but at the same time, that layers it is shown in the two-dimensional, and then you wanted to show to the decision makers or to your boss. So he will be able to understand or visualize if you are able to show something, field photographs or a video of the field. So then it will immediately give an impact or a better impact. So that means the sound and video are very effective. And then those sound and video you can basically integrate with your GIS package. One is inputting and then correcting errors and making the data ready, and then finally you do some analysis. But at the same time, if you wanted to present it, if you add this sound and video, so then it will give you more effective, and it helps the decision makers for fast and quick decisions. So these functionalities can be integrated as part of GIS. So that's why. So it is more of a multimedia functionalities which can be brought into GIS. So another is developing hypermedia spatial databases. So instead of having the exact relational database, you also add this multimedia functionalities. So it will be more effective, you can use them. So nowadays, the technology is of more of mobile technology. So everybody now, if you see any TV and any paper, newspaper advertisement, you get a lot of advertisement on the smartphones. So now smartphones, people say that it can do so many functions. What your desktop also does. So starting from your internet connectivity to emailing service, and then at the same time, if it is enabled 3G, you get a lot of data. You can at a real time, and then you can also see in a movie and video mode, and then it helps basically for various applications. So the same thing happens when you use it for a remote sensing and GIS environment. So the same mobile, download that Google app, and then you can also download Google app and then try directly bring that Bowen images, and on that and also overlay the layers, and then start updating the information. So this mobile, and then basically wireless technologies. Nowadays some of the countries, so even the some cities, so they enabled wireless for the whole city. Even our government also, that they announce, so they bring wireless internet connectivity. Nowadays, at least in airports, we have the connectivity here at some of the places, but more and more cities, so people or government wanted to bring the wireless connectivity so that people are able to use that for many applications, including your GIS. So what are the enabling technologies? So one is a faster hardware, so that means your processing capabilities, the RAM and then storage, etc. And distributed computing is basically if you are analyzing the data for the world, for the climate change studies. So, and then you have to use a huge amount of data. So that's why when you analyze the data, it is also the grid size. So if you say grid cell is maybe 10 kilometer by 10 kilometer, 25 kilometer by 25, or off grid, off degree. So off grid means around 60 kilometer by 60 kilometers. But if you reduce this one size of that pixel, then your amount of data increases. Suppose if you go from 1 degree to half degree to quarter degree, and then you wanted to process, so there also your processing requirements increases. So for that, distributed computing is, instead of doing at one place, you compute at different places, so that your processing can be done at a faster rate. And then as I said, that mobile and wireless is the technology which are picking up, and then they are going to help in terms of creating a data, in terms of generating a lot of information, as I mentioned, like a crowdsourcing, and then they can also use for analysis purpose also. Another is service oriented architecture. It is basically the standard what we use in the wireless and internet technologies. And then there are, nowadays people also talk about big data. So large data repositories are taking place, and how to use that large data repositories for different and various applications. And then GIS softwares, when you start GIS softwares, there used to be proprietary softwares, card-based softwares initially. And then even you talk about 1995, 2000, till 2000 also, limited softwares are there which can be used freely. But nowadays we have many GIS softwares, imaging analysis, image processing softwares, and then these processing softwares basically developed on open source, and then you can also start using them. One is the commercial based proprietary, where you have large functionalities, and then many softwares are there from desktop level to internet level. So many softwares have been developed. So, and then those are all the are also available freely. If you talk about open source, so if you, I can give an example like a OSGeo. So this is one consortium, one place where you get a lot of softwares for various applications, from desktop applications to WebGIS applications to portal development, and then catalog services, and then for various services as per the standards, like if you talk about OSGeo and then ISO TC international standards. So they also suggest that different services on the web, the WMS services and WCS and WFS services, which will be available on the online. Another is if you talk about the technologies, as I mentioned, technological trends. So as I mentioned earlier, like a data, hardware, software, and then internet. So the data basically, if you talk about a satellite data, so we started with a multispectral and then panchromatic. Now we talk about a hyperspectral. And then you can also talk about microwave data also. Earlier microwave data is available for some of the bands, and now it is also available for longer wavelength bands, and then there you also have a high resolution of microwave data. Microwave data advantage is, you might have told already. So we are able to get the data whenever there is a clouds are also there. And then when you talk about a data, it used to be low spatial resolution. When we started, it used to be 1 kilometer for meteorological satellites, and then it used to be 100 meters. First Landsat, when it came, it used to be 80-meter resolution. So now we are talking about one less than a meter and then 50 centimeters. Even India also, we are planning to launch Cartosat 3 with 25 centimeter resolution. So you can imagine that how it is going to help. In addition to this, these satellites, if you talk about the remote sensing, so the revisit time is again, revisited time is very less. If somebody is monitoring in a real time, so in a remote sensing, it's very difficult to get the data in real time. But India is going to launch some GIS satellite, which is there at geostationary, and then it is always looking at India and surroundings. So there you will be able to get information frequently, and instantly you can also get. On the same day, you can get a lot of information within 5 minutes, 10 minutes interval. That was not possible when you talk about what is that, remote sensing satellites, sun synchronous satellites. So this GRI sat is to be, you have to, it's very advantageous. If it gives 50-meter resolution, but giving at the, which is satellite is there far off, 36,000 kilometers. So it will be basically, when it comes, it will be also revolutionizing our availability of the data. So what we are talking is repeativity of 22 days and 28 days or 18 days. So all these things will be changed when we have the satellite which gives information on a continuous basis. And then we used to have a monochromic data like a pan data, and then now we are talking about a stereo imaging. And then hardware is, as I already mentioned, like workstation based PC to mobile level. Software is desktop, it used to be standalone. And then you have a WebGIS and mobile GIS. So these are there are many softwares are there. WebGIS is basically to view whatever is created at the server level, and then client will be able to query and then display the information and then attributes, etc. So mobile is, you take your mobile unit to the ground and then you are able to collect the information, and then automatically you can also update using a GPRS network. So internet is playing a very important role. So I also kept one slide where now NKN connectivity is basically revolutionizing use of data on the internet. It is, we are talking about a gigabit speed, and then all over the world also. So people are come out with gigabit speed, and then the data transfer rates is very high. And then we also have services like web services, Google Earth and Whirlwind, etc. And then we have a Bhuvan also. Now this is also one more side telling that influence of IT trends in a GIS environment. Is basically how that computer has evolved in that time. So pervasive high performance computing. So it used to be earlier what we used to talk about is few MBs of data, and then we used to talk about RAM of maybe 1 MB, 2 MB. So now we are talking about what is that? 8 GB, 16 GB, which is 1000 times better than earlier. And then the processing capability also is increasing. And then storage also we used to talk in MB. So it used to be 100 MB storage or 200 MB storage. So now we are talking about 500 GB or 1 terabytes storage. And then connectivity is also one more thing, what we are talking about, digital connectivity. So it also plays very important role. And then another important thing, geographic data capture and compilation. So capture means the data is there, how to capture the data. Basically, earlier we used to do through digitization, and now we are going for the scanning. And then when you do digitization or scanning, if you do it manually, so then it requires a time. And then if it is done in a automatic method or semi-automatic method, and then able to correct the mistakes, errors, so then you can generate a themes at a faster rates. So those are all also helping. Another is geographic data management. So we talk about earlier talking about a storage requirement. Data what we generate used to be very limited. Now we are able to generate a huge database, geographical database, and how to bring them that coming from different sources and integrate them for various analysis purpose. Another is standards and open systems. So standards is, as I mentioned earlier also, you have standards at international level and the national level, and then you have standards for a GIS, and then there are so many organizations, institutions which are working for standardizing, so that when you combine together all the information, we can integrate them seamlessly. So that is the advantage of that. So to give an example, if you see that example in 1980, that CPU is 2 megahertz. So now we are talking about 3 gigahertz. And the memory used to be 128 kilobytes. Now we talk about a 1 GB. So 128 is almost 1/10 of a MB. And then 1 GB to 1 MB is 1000 times. So it is 10,000 times the memory is increased. And disk space used to be 10 MB. So now we are talking about a 160 GB. So it is something like a 160 into 1000. So it is 1,60,000 bytes. See, 1 GB is 1000 MB. So like 1,60,000 megabytes. So, and then if it is a 10 lakh, so it becomes divided by 10 also. It becomes 16,000 times. So 1 MB to 16,000 times it has increased the storage space. CPUs, it is something 1500 times faster. Memory is 8,000. Disk is 16,000. It is giving an example, but still higher capacity also have come up in this. Another is grid computing. What I am telling is, One is a cloud computing, one more is a grid computing. So there are some packages which comes along with you. They come with processing capabilities. They divide the processing and then distribute among the smaller computing nodes. And all these nodes, so they will be able to process the data and then bring back. So it is basically helping to doing the processing at a faster rate, or distribute the, suppose if you have to process the computing facility, and then what we are doing is we are asking the main computer to distribute the job and then work done at different systems and bring back again and then combine together. So that is what a grid computing. So you talk about different places, how much they are doing it. You're talking about teraflops at different places. So there are different softwares, like Globus middleware is one software. It will also facilitate this grid computing. So we talked about what is that? Grid computing. We talked about, and then on the improved computing facilities. So now what we are talking is still enhanced computing, like this is cloud computing. So in that cloud computing is basically using resources on the cloud. It can be a software services, it can be hardware services, it is a platform services. So there are various services are available on the network, and then you can able to if you can able to use that, so it will also facilitate you for computing. And then basically your work you can get it done on the cloud. Basically that is the purpose of this. So instead of taking headache of buying the systems and then buying the hard software and then buying the application or models, and then instead of that you can do it on the network environment on a payment basis. Even suppose some example is we are conducting some exam, suppose online exam, and then there are many people are participating, and then we try to do ourselves. So we should have a system, we should have a software, everything should work well, so that we are able to conduct this. But at the same time, if the load increases, so at one place we will not be able to do, or one server may not help. So that type of requirement you can also distribute. I heard that Google, instead of to work faster, I heard that they have kept many number of servers all across the world. So it is unimaginable. I heard that somebody was telling it has reached 1 lakh servers which are distributed, suppose for all whatever you are doing using a Google. So it is not only servers, so the data storage also. So and then it is distributed. So and then according to your query, it will be able to pick up and process and then send back your request. So it is a huge task. So and then the users are many, huge number of users. How to manage those things? So this cloud computing is one environment. It is basically helps in that. So basically you can use from web browser, it can be from a mobile or be from desktop, and then you can use it for various things, for analyzing the things and communicate and visualize. So there are various requirement. It can be a software application, it can be a storage, you can call back the information and then do some analysis, etc. And this interoperability, I think we were discussing earlier, is basically seamless integration of the data with the common standards. So if it is as simple as that, suppose we are carrying a mobile, and then every mobile normally have a different charging unit. And then when you go to different place, if you find different, then it will be difficult. So suppose we talk about even our vehicles. So that these vehicles also comes with their own toolkits. So if they can standardize those things, so then when you are not you are not carrying your own toolkit, if somebody is carrying and then they are the same standard, so you can use that toolkit for your own repairing of your vehicle or etc. So similarly, in a GIS also many people generate information, and that information is done differently, and then for the same area, even if you wanted to integrate, it will be difficult. So if it is having a standard format, standard georeferencing, and then standard datum what you take, so then they can be seamlessly can be combined together. So this OGC and ISOTC, they suggest web map service. So suppose you wanted to take some data directly, so you can get that web map services. It can generate a JPEG image and give it. Another is a web feature services. So it is something like generating or using that vector layer. Suppose if you take a web map service, you can take that data, but it cannot be used. It can be used only for visualization, keeping as a background. But features, what you can do is that vector information directly you can call, and then that you can analyze for further application of that web map services. It can be a line, it can be a road, it can be a canal line information basically. Web coverage services is something like a raster data, like in a GIS, when in a desktop you create, there is a raster layer, so then you can call that and then you can start analyzing it for different applications. So then you also have a catalog services, geography markup language, and then web map connected. There are standards are there, standard formats are there. So, and then if they are all there in the interoperable mode, so then you can easily use them and then come up again. See, another component is web. Normally, it is easy to display and view the information. If suppose you wanted to give some functionality like combining some two layers or generating a buffer and other thing, so we have to develop those tools on in the web environments. So in that case, earlier what we are doing is, suppose you take Google image or some road information, you can bring that and then you can do some analysis and generate another output. So these are all some web map services. So in case of this web mapping with WMS, suppose there is a satellite image is there, and then on that you are bringing some vector information, you can overlay there, and then you can see that how it looks or how the changes has taken place, or it can be used for further analysis. So the example is here is, suppose you wanted to generate, there are two line informations are there, you want to generate a buffer for that. So you carry out processing on that web processing services, and then you can generate output with the buffering component of analysis. Another is mobile mapping. In mobile mapping is what is happening is, you talk about a GIS mapping. Suppose I wanted to create a agriculture information system for a particular area. So what I do is I collect the information, manual information, satellite information, I scan something and then start digitizing it. But suppose I create this and then later on I found that some new addition has come on the ground. So that information is not available, may not be visible exactly on the satellite data, and topography map also it is not there. So how to get that information? So you take your surveying equipment to there and then do the survey and get the information and update. So that way also we can do it, but for that you require the survey equipment, which is also costing. So instead of that, you can also take your GPS there, collect the information, and then bring back to that your computer, and then you can update. Another is you can go to the ground using different software packages like collecting, inputting a component of a GIS is also uploaded into mobile unit, and that mobile unit also is integrated with a GPS. So that mobile unit I take to the ground, and then I collect the information using already GIS type of software which is there to collect. I collect the information, and then because this is a mobile unit, you can also connect it to the internet. So then I can directly connect to the internet, ask to upload it to my server. So that means I can upload information using the mobile device. So directly I am getting into the server. This is also one way of telling that your crowdsourcing. So I started with that, like recent this one cyclone effect, and then crowdsourcing example. So before all these things, so when mobile started coming, and then this mobile also the technology was changing, 2G, 3G, and etc. And then as part of a policy for this mobile, so they also started. Say suppose somebody use a mobile for some application, some bad intention, and police wanted to track that mobile. Somebody used for some creating a nuisance or destroy something. So if the person is use the mobile, so then this mobile providers, they can also locate where it is located. So there is a policy in America that any mobile if you use, so they should be able to provide information within 100 meters where it is the mobile is located. So that means that is using without your GPS. So that giving information based on the mobile tower connectivity and the strength of the signal, they will be able to find out the location within 100 meters. So suppose if it is a GIS integrated, GPS integrated, it can also collect the GPS information and also collect the location information. This location information is it will play an important role for further application. Suppose I carry a mobile, and then I know that there are some emergency services are available, like emergency call, suppose maybe 100 for police service or some number for health services. So if you press that button, so you will be able to get the assistance where you are located. So that means there are services are available for the mobile. So that is why these are all called mobile based service, mobile or location based services. Another important thing is in these mobiles, you can also upload your maps, and then using your own location, using the GPS, you can also try to find out what are all the nearest health centers. Suppose I feel uncomfortable, I feel that I am affected with some problem. So then I immediately require to go to, I require assistance from the health centers. So you can also load the map onto that, and then try to ask the mobile locate health centers within 1 kilometer range, so that I can move fast. So then what it can do is, on the basis of the point where you are located, it will generate a buffer, and within that buffer, if it is able to intersect with some health centers, so it will pop up those health centers. So you are able to use those health centers and then go there and get the service. Similarly, there are a number of services. So it can be finding out a restaurant of your liking. There are so many things, or cinema halls, or you need petrol, you wanted to find out the petrol pumps near to that. One is for a tracking, if you wanted to go from place to place. Another is assistance, like a public health assistance. And then another is monitoring. So the continuous, if you wanted to monitor. And then suppose nowadays all the news channels are coming that they will be continuously tracking that cyclone effect. So that type of some monitoring also you can do using location, and then also providing information. So what are all the locations where you can find petrol pumps or something like that. So how it is working? It is working based on the mobile communication. See, all these mobiles are connected with their own mobile networks, and then those networks are further connected with internet service providers. And then when I send an information to mobile tower, so it further connect to the other networks, the internets, and then provide this information. So I can call what are the maps of for that particular city or particular place, and then what is the information is there on that. And then based on that information and what I required, so it will try to generate, analyze and generate information and give it to you. So it is done everything on the wireless environment. So if you see that, suppose if you have a GIS and then internet, you can call it as web GIS. And then again GIS and then mobile devices, you can call mobile GIS. And internet and mobile devices, that is mobile internet. See, one of the example of using communication technology is, it is something like a fleet management. The fleet is number of vehicles. It can be the trucks, fleet of trucks, and fleet of the taxis, or it's a fleet of something else. So he wanted to see that how this fleet is used for different purposes, and how whether we can monitor those things. So this thing it can be done basically. It is done on a GPS based fleet monitoring system. Basically nowadays you might have heard about Delhi buses. So government buses, they install GPS so that they continuously monitor how this vehicle is flying, and then getting the information where it is located. And then even I have seen some of the foreign countries, so they give that the bus arrival and departures, so they give the exact times. In India we don't know that when where the buses are there for going to different places. Even these foreign, we have seen that there are bus terminals, there are digital displays are placed. So this number of bus is going to come at this time and going to leave at this time. So it is all possible because if you integrate with the GPS information, and then you continuously monitor that coming in, coming out of vehicles. So here what I am going to tell is, there is a private company which has used this technology linking through the satellite. So what is done is, one is the GPS is there on the vehicles, another is that information is again uploaded to the server using a satellite connectivity, so that your server will be able to monitor continuously how this fleet is moving and how much distance it is covering, so that it will help for monitoring efficient use of that. In the same the mobile crowdsourcing application, so what was done is like whatever disaster now cyclone has happened. So in 2013 there was a disaster happened at Kedarnath in Uttarakhand, Himalayas. So heavy rainfall, and then sudden outburst of water coming from the lake, and then because of lot of water is flowing, it also destroyed all the way, even the Kedarnath temple, etc. And there's a lot of culverts and bridges are damaged. So there was a project has been carried out, and then this crowdsourcing application has been applied, and then information is collected directly from the local people. So they collected huge number of points of information, around 20,000 points of data was collected. So and then there is a developed, like as I mentioned, like for the cyclone, NRSA what has developed. Here also NRSA was involved, IERS was involved, DST was involved, Wadia Institute of Himalayan Geology is involved, Srinagar University, like many other are involved in this, and then generated a huge information base. So basically, this information is going to help the decision makers. So further, what is that? Use of this for further, what is that? Infrastructure, etc. They can carry out. See what are the damages here later. So that Bhuvan points for this, it is given 2,621, and bridges and culverted, the information collected about buildings 103, and land cover resources and landslide, how many landslides were picked, and that. So these are the points showing that, and finally these points can be collected on the ground, and then it can be collected at the local place and take the photograph, and that also tag that latitude, longitude, and then again send back to the server so that it can be sit directly on the server. So like all these points, what is coming is coming from the faraway places, and then uploaded to the server directly. As I mentioned initially also that 3D and virtual GIS, when the whole Australia has came forward with billions of dollars to create a virtual Australia. So that means you bring the whole earth of whole area of Australia in terms of satellite data, and then a lot of digital elevation information, and then visualize actually what is there on the ground, and then bringing to the in this network environment, so that it can be used for visualization, and it can be used for further decision making and effective use of that information for various applications. So it is a huge development what is taking place. When you talk about a GIS, we normally talk about a two-dimensional map and then one height information. So that height information is used to create a three-dimensional picture. Here we are talking about one height, so that's why it is termed as a 2.5D. So it cannot be 3D. So 3D means at one same location of latitude, longitude, you should have a multiple height information, like a log information of a for oil or drilling point for the water. So all this information, and then that information you can use it. It is also used for medical applications. Many times it is difficult to collect the information on the ground on continuous basis and in real time. So for that, the new technology has been developed. So that is called a sensor network. So you have the sensors for collecting the information like temperature, humidity, the rainfall, and then it can be also used for climate studies, air pollution levels. So you can collect that all information and directly send to the server without any manual intervention. And all those things can be again combined with some models, and then you can also predict what is going to happen. Suppose if it can be also a simple example is some flash flood comes sometimes. So flash floods are coming because in upper catchment there are a lot of rain taking place. Suppose if you are able to you get the real information, like if rainfall is going to occur with a certain intensity, and then if you have collected that information in real time, and then when the rain occurs, so then you will also know that within this time, because this much of rain has taken place, water is going to gushing down, and then it will also creating a havoc. It is something like similar to tsunami. So when tsunami occurs in deep sea, and then that upliftment of the plates or something so takes place, and then the water is displaced from there, and then it comes try to come to the shore. So then if you, there also they use different models. Here also in rainfall case we can also use different models. So if you integrate this automatic sensor network and then also integrate that into the analysis of models, so those all things basically help you to find out when this damage is going to happen, when the disaster is going to happen at a certain place. So if it is happening maybe 500 kilometers deep sea, and then to reach the shore maybe it takes time. So maybe 1 hour, maybe 2 hours. So it all those calculations can be done and warn the people so that people and property can be saved. So these are the different sensors like. So these sensors will be used basically, and then they can be integrated with the different model. User wanted to predict the future based on this network. So this is also new taking place, new development. Another is GIS as I mentioned earlier. ISRO has designed geo-imaging satellite. It will have the resolution of 50 meters to 1.5 kilometers. You have a spectral of visible near infrared and then thermal bands. And then it is there at a geostationary. The advantage of this, covering the area of India and surrounding, will provide near real-time pictures. So that is the one advantage. If you have the satellite which is looking always in a particular area, in the other case it is going repeatedly, and then it takes time to come back to the same place. And then sometimes if it is, I suppose disaster is going to happen in one place, you can also concentrate on that place. And then it is also planned that is something 2016 and 17. Another thing is new development what is taking place is GeoNetcast. Suppose there are, as I mentioned, like so many sensors, so many informations are coming from different sources like meteorological satellite, remote sensing satellites, and then you have a GIS information, rainfall, humidity. A lot of information is generated at all over the world. All this information what is generated, normally it is again uplink to some satellite, and that satellite can download back to the earth. So something like that, if you wanted to collect information, that is what is done is in Europe is they are doing a UMetcast, standard hardware indicative cast is, suppose you wanted to collect the information for whole your own place. So you can also collect that information. There are some meteorological communication satellites which are placed at again geostationary. So those things they communicate back a lot of information. It's hundreds of parameters you will get that. So these informations can be used for various analyses, weather forecasting and climatic models, and then even regional level studies. So those things also can be used. So here it is. The cost of getting that type of information from directly from the satellite is around 3,200 what is mentioned here. So as I mentioned, these high-speed networks, it is playing a very important role, and then we are also using this one of the networks so that we are able to give the live programs without disturbance. In between some that hardware software we upgraded here. And then configuration, there are some problems are there, but otherwise when we started this program, so it was done effectively, and then I hope we will be also doing future. These plays a role. It is not only for this the classroom. It can be also used for for your grid computing and cloud computing. These networks will be very effective if you use it. So what I do is I'll not talk about this again. General things about telling about how it is the technology is influencing, helping in and having a better processing capabilities, etc. And then in a hardware also we have that parallel computing. So instead of having only one processor, you can have a multiple processor. There is called also CUDA processor or GPU processing. So where multiple processors parallelly can be done, so that analysis can also done faster. And then there are so many applications nowadays. Many applications have come up. So GIS can be used for many applications. And then it used to be in the past. If you see that, we are talking about pictures and then maps, etc. Now we are talking about a visual simulation, virtual reality, and then how to do it in a real environment. So that are the developments what are taking place. And then final one is when we started GIS, the major work, chunk of the work is basically data conversion, and then it used to be attribute taking of 15%, and still analysis is also very limited. So now the present and the future is you have the data and then everything is there. So now you have to concentrate more on analysis and modeling so that it can be used for a variety of applications and future predictions. So with this, I thank you all. I think it is a long lecture. Maybe it's a generalized topic. Maybe you got bored, but I hope that it is useful for all of you. And then I request if you have some questions, I'll take them. I'm also happy that today the lecture there was no intervention or there is no breaks. So that was one thing we lost. We faced a lot of problems. So thank you all. So I'll come back again maybe in 2-3 minutes back with your answering for questions. So there is a question from Mayur P. Raj. Try to cover topics like KML, GML, and other web services to develop customized applications. So there is we also conducted some program earlier, web services, Geo web services. So I'll see that whether we can share that information. So there it has covered completely on KML and GML and web services. So I think you hope we'll get that total information on that. Then already we are overloaded with topics, and then we have some application topics in the next week. So probably will not be able to cover any additional lectures, but I'll provide that information. So I'll ask my people to provide that information. Another is there are issues of examinations, again Rakesh Kumar, coming from November 10th to 20th. So you ask your coordinators wherever you are giving examinations to be in touch with us, so that we will suggest some alternative. Abhishek is asking about how to get GISAT data. GISAT, as I mentioned, it is a future satellite, not yet launched. So the time frame is 2016 and 17. So once it is launched, probably we all get the data. Like you, everybody can get the data. So normally, any data which normally comes from the NRSC or from ISRO center, whichever is designated. So people can get the data. Anand Krishnan, sir, I have one suggestion. I have heard that customization and development is having very good scope in GIS. See, it is something like it is there, scope is there. So, it is not like one lecture. So, suppose you have a capability of front-end development and back-end development and use the GIS tools, and then all those things you can integrate, and then you can carry out a project so that you can develop an expertise. So for that you require some programming skills, front-end programming skills, and then database skills, so that you can combine all those things together, and then suppose you can take up projects, and it will also help. So it is scope is there, but the one has to work on that so that you develop your own expertise. NGRA Hyderabad, I wanted do UTM projection, but my study area is falling in two UTM zones. How to project it? So there are, if you go to that help files in the particular software, I heard that there are the help is given how to project if something falls on two UTM zones. You try. If you don't get it again, you come back to me. Then I'll tell that what has to be done. So then I can also look into that and help on that. So one more is irrigation and CAD department. Please increase the volume. I hope it is done. Abhishek, what components of to develop agricultural problem finding solve using GIS? See, first of all, when you say that you wanted to use for a particular problem, so then you have to analyze what are the requirements for that problem. Like you say, agriculture problem. So agriculture is also a vast topic. So you are talking about in terms of crop acreage and production, yield and diseases. So you say that particular to that, then your input other information also changes. So what type of satellite data is required, and what are the other ancillary data is required, also depending upon, it depends upon that. And then once you bring all those things, then you can analyze and come out with a solution for that. So you have to be specific, then you can think of solution for that. Nidhi Rawat, please explain me the complete process of customization of school this complete process of customization for school mapping, for planning for school access. What I understand is you wanted to locate the schools. So for that, you have to create a database identifying the schools. Either you use satellite data, that is one process, locate the schools, or you get the information from the GPS, collect the information on the ground, and then you create a map. And then remaining information is you give attributes for different schools, category, and then the specialization, and then all those informations. And that can be again generate different layers. And then you can also generate a query process, what type of query people wanted. Try to find out admission process, or try to find out school strength, and then which way you wanted to use. So that information you can also built in and develop a tools, and then you can give a front end tools like Visual Basic or other things, and then database connectivity, and you click on the buttons and then that button is again connected with that different queries. So you can come out with that what exactly need analysis has to be carried out, and then on the basis of need analysis you build some queries, generate requirement of queries, and that queries can be used for development of school mapping. So one has to go in a detail and then discuss the requirements, and then based on the requirements you can also you can come out with what is the software tools are required, what are the front-end tools are required. So all those things can be worked out. How can we, Dr. Bhamu Aurangabad, how we can use Internet of Things with GIS? So Internet, see basically when you talk about the Internet, so GIS also become part of the Internet. See when you say web GIS, there are some softwares are there, it works on the Internet. So there are servers are there, you can create some information and keep on the server. And then there are portals are there, web portals like a Bhuvan is there and a Google Earth is there. So there are many portals, they work on a client's environment. You can access the information, visualize the information, and now web processing tools are also developing on the internet, so that GIS also analysis also incorporated in this GIS environment. So internet is becoming an integral part, but suppose somebody wanted to do standalone, that also can be done. So that application you want that you wanted to use only for internal, your own department, your own people. So then you don't require to put on the internet. Increase. How to get satellite data for research, Abhishek? It is satellite data. Many NRSC also give more subsidized rate for the students. Maybe 25% of that. Or old data they may give free, but there are so many other satellites like Landsat. They give free data, and then SRTM, DM data also comes free. You basically have to download. You have to go to that ESGS website, and then you have to select and then give the coordinates, and then you can start downloading. Try to find out first and then download this thing. Abhishek, again, please give some web link for GIS and remote sensing. Abstract. So there are a lot of sites are available having GIS information. One is Geography Network from the ESRI. So they are also having a study material. And then even IIRS also we have our e-learning program which is coming up. So in near future you can get a lot of information on the web. Anytime if you want to learn, so that information is generated. So in the soon we are going to launch that e-learning program. So another thing is CCRS is there, Canadian Geographic Information System, USGS is there, and NASA. There are so many websites which provide information. And Nidhi Rawat is again asking that school. Let's see, one is Nidhi I wanted to tell is, first of all you identify your problem, and then what are the solution you wanted to give. On the basis of that, basically you can develop the customization what is required. Then you require to formulate what are the questions required to be answered. And then those questions and again also linked to your database, spatial information, and as well as your attribute information. And then when you click on that, that operation has to be done at the background. So then your output should be able to display. You wanted to know that suppose schools which are having a capacity of maybe 500 students or capacity of 1000 students, so then it will be able to display those schools. So that means you have to know that what is required, so accordingly you should be able to develop. Josefina Paul, please give me some more data, picture and spatial and demo class with those on quantum GIS. Okay, with that, thank you for your for the time. I think everybody is busy with their own schedule of lectures at their own place. Thank you for attending the lectures. Any questions you can post it on us, so then we'll able to help you all. Thank you.